In this video, we're going to talk about identifying functions. So our first point we have up here is a definition. It says a function is a relation, which a relation is just a set of ordered pairs, so x, y coordinates. So a function is a relation where one value depends on another value. So now down here, we're going to talk about what domain and range are. Okay, so in our definition of a function, when it said values, that's talking about our domain and range, or our x values and our y values. Okay, so for the domain is the set of x values. Domain, x values, also known as the input. So those three words mean the same thing. Domain, x values, input. Range is the set of y values, also known as the output. So domain, range, x, y, input, output. Domain, x values, input. Range, y values, output. Those are all the same thing. Whenever we look at a function, we're going to list our domain or our x values or our input in order from least to greatest inside of braces. These are called braces. Okay, so notice we have -2, 0, 1, 5. Those are in order from least to greatest. We also want to list our range or our output in order from least to greatest. Okay, a couple of more points down here, and then we'll look at some examples. For an equation or a set of ordered pairs to be a function, it has to satisfy these things. Every input must have exactly one output. Okay, so I can't have any repeating x values. Every time I input an x value, it has to give me just one y value or one output. We cannot input a number and get two different output values. So when I'm talking about my function, it's going to look, if it's a linear function, it's going to look like slope-intercept form. So if I input a value for x, so let's say I input 2, I can't get more than one output for 2. So I can't put in 2 and get -1 and 7. Can't work. Each x value may only be used once. One x value cannot have more than one y value. So those are basically the rules of how to identify a function. So now we're going to look at some examples of identifying functions. We will identify functions that are in 5 different formats. The first of which being a table of ordered pairs. So we're going to look at 2 examples of a table. One will be a function, one will not be a function. The next way is a list of ordered pairs. So here, examples 3 and 4 will be lists. The third way is called a mapping diagram. Here's our mapping diagrams. We'll talk about a way, kind of a trick to remember which of those is a function and which is not. Then we'll look at some graphs and we'll look at some equations. Okay, so let's start off looking at number 1 here. Number 1, they've given us a table. It's an XY table. Okay, so these are all of our x values, these are all of our y values. So this is our domain, this is our range. So it says write the domain and the range. So I'm going to start by putting my brace there. Okay, I'm going to look and put them in order. Well, it just so happens these are in order. So I put 2, 5, 7, 10, 11. That's my domain. And then I write my range. Well, I look here, I have 3, 2, 4, 3, 8. So I need to look and say 2, 3, 4, 8. 2, 3, 4, 8. Notice there were 2 3s here, but I only wrote 1 3 in my range. I don't have to rewrite that value. I just write it one time. Okay, so now I'm going to look and see if it satisfies some of my rules. Well, to be a function, I can't have any repeating x values. So I need to look and see if any of my x values repeat, and they don't. So this would be a function. Okay, let's look at number 2. Once again, write down our domain. 1, 2, 3, 2, -1. So I need to start with -1, then 1. I only have to write 1, 2, and then 3. Now look at my range. 1, 2, 3, -2, -1. So now I'm going to start with -2, -1, and then 1, 2, 3. Okay, that's my range. Now let's see if it's a function. Do I have any x values that repeat? 1, 2, 3, 2. So look, I have 2 2s. Here I input 2 and I got +2. Here I input 2 and got -2. That is not a function. You can only have one output value for a certain input. Okay. Number 3 is a list of ordered pairs. So just like a table, but now it's a list instead of actually putting them in a table. So I have my domain 3, 1, -2, 1, and -2. So this will be a parentheses there. So I list my domain. Okay. My least range would be -2. There's 2 of those, so I'll have to write it once. 1 and 3. Okay, my range 6, 7, 5, 9. So I'm going to start with 5, 6, 7, and then 9. So there's my range. So now I want to look, do any of my x values repeat? 3, 1, -2, 1. Here I had 1, 7. Here I had 1, 5. Not a function because that x value of 1 repeated. And look, also -2 repeated. Okay, so if -2 gives me 5, -2 cannot also give me cannot also give me 9 as my output. It can only have one output for each input. Okay, now let's look at this one. Here are my points: 1, 5, 2, 5, 3, 5, 4, 5, and 5, 5. So list my domain. My domain is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my range is only one number, 5. That's all I have to put. Okay, now look, my output repeated, right? 5, 5, 5, 5, 5, but that's okay. I can have the same output as long as my inputs are different. Okay, so all of my inputs are different. 1, 2, 3, 4, 5. So this would be a function because none of my x coordinates repeat. Okay, now let's look at 5 and 6. 5 and 6 are mapping diagrams. Okay, and we're going to talk about, there's a little trick to identifying if a mapping diagram is a function or not. But first, let's just look at the domain and the range. Okay, so whenever they give us a mapping diagram, our x coordinates will be on the left, our y coordinates will be on the right. So our domain here, we would have 1, 3, 7, 1, 3, 7. And our range, 0 to -9, write them in order, -9, 0, and 2. Okay, so now on a mapping diagram, we want to read it, we want to look at it from left to right, and let's think about an open mouth and a closed mouth. Okay, so right here, if we look here, these two arrows go here and it also goes here. So that would be kind of like an open mouth, right? If we look at this one, this arrow goes to 2 and this arrow goes to 2, forming sort of a closed mouth over here. Okay, well, how to remember this? Sometimes if you have a sibling or something, and sometimes we might get frustrated with them, and if we open our mouth and say something mean to them, then we're going to get in trouble. All right, but if we would have just kept our mouth closed and not say anything mean, then we don't get in trouble, right? So kind of how to remember this: if we have an open mouth, that's no good, right? Sometimes that gets us in trouble. So open mouth, not a function. Okay, but down here, look, we have a closed mouth. Okay, so we kept our cool there, kept our mouth closed, did a good job. That is a function. Okay, so let's go ahead and write our domain and range here. Okay, so -3, 8, and 0. So -3, 0, and 8. And our range is just 2 and 5. Okay, so that is 1 through 3, an example of a function for a table and not a function for a table, also for a list and a mapping diagram. Okay, so the next way that we're going to have to identify if it's a function or not is from a graph, and the last way is an equation. So let's look at some graphs here. First graph we're going to look at looks like this right here. Okay, if we notice, this is a straight line. So that's kind of the graphs we've been talking about that are linear. Okay, so that's a linear. And we could write this in the form of y equals mx plus b. Okay, so with graphs, we're going to do a test that is called the vertical line test, okay, or the VLT. All right, so how you do the vertical line test, you take your pencil or any kind of vertical line, all right, and you run your pencil through the graph, and if at any point your line, the pen that you're using, if at any point there are 2 points on the line that are on top of each other, then this is not a function. Okay, well, if we look here, at no point are there 2 points that are on top of each other vertical. Okay, so we would say this passes the vertical line test, and that is a function. Okay, let's look at the next one. Now we have a circle as our graph. Well, if we take our vertical line and we run it across our graph, there, a lot of points where we have a point on top and a point on bottom, and they're right on top of each other. So this one does not pass the vertical line test, so it's not a function. Okay, now let's look down here. This is called a parabola. Okay, this is a quadratic function. We'll look at the equation of this in just a second. Okay, so let's do the vertical line test. So bringing it across here, still good, still good, still good. Okay, all good. And this graph will be going up at an angle like this, both directions. So there will never be points that are stacked on top of each other, so that will be a function. Okay, and the last graph we're going to look at, this is already a vertical line. Okay, so if we remember, this would be like x equals a number, right? Our slope is undefined, right? There is no y-intercept. That's stuff we've learned previously. Okay, but if I do the vertical line test, when I get to my graph, whoa, all those points are on top of each other, right? So we would say that that is not a function. Okay, so for graphs, we want to use the vertical line test to test and see if we have any points that are on top of each other. If our graph does have points on top of each other, then it is not a function. And if it does not have any points on top of each other, then it is a function. Okay, the last thing we're going to look at on identifying functions are some equations. Okay, so in order to tell if an equation is a function, we have to look at a couple different things. First of all, if an equation, 99% of the time, if an equation is written in slope-intercept form, y equals mx plus b, then it is a function because it's a straight line. Okay, we know there is an example of a special equation that would not be a function, and we'll get to that in just a second. Okay, and some of the other functions we're going to talk about are quadratic functions. That's when a variable x or y has an exponent of 2. A cubic function, that's when the variable x or y has an exponent of 3. So we'll look at those in just a second. Okay, so our first example here says y equals 2/3 x minus 4. That's in slope-intercept form. That's my y-intercept, that's my slope, that's going to be a straight line. Okay, so yes, that is a function. Okay, all right, let's look at this one. Y equals 8x squared plus 3. Okay, well, if I were to graph this, this is going to be a parabola because this is what's called a quadratic function because this x has an exponent of 2. Okay, well, if I want to just plug in some values here, okay, what if I plugged in 2 for x? Okay, well, 2 squared is 4. 4 times 8 is 32. 32 plus 3 is 35. So a point that's on this line is 2, 35. And there's no other value I could get for 2. Okay, so I know that yes, that is a function. Okay, look right here, it says y equals 5. Well, if I remember Hoy-Vux, I know that that is a horizontal line through 5. And that will pass the vertical line test. So that's good. Okay, so 3 for 3 so far. Next one is x equals -4. Well, if I remember also Hoy-Vux, this is a vertical line. And we saw on the previous piece of paper about graphs that this will not pass the vertical line test. So that would be no. My answer would be no, that would not be a function. Okay, the last one down here on the bottom, we have x squared plus y squared equals 25. Okay, we're going to learn that when we see an x that has a squared and a y that's squared, that this is going to be a circle graph. So if we looked previously, we saw that a circle graph did not pass the vertical line test, so that is not a function. Okay, well, let's plug in a number here and see what we get. If we plug in 5 for x, okay, we're going to have 5 squared plus y squared equals 25. Okay, well, here if I do 5 squared, that's 25, plus y squared equals 25. I could subtract 25 from both sides, and I get y squared equals 0. If I take the square root of that, then y equals 0. So I know that point's on my line 0, 0. Okay, which is okay. That only gives me, when I input 0 for x, it only gives me one output for y. However, if I were to input some other numbers, I would get 2 outputs for certain numbers. Because think about it, if I get y squared equals, and let's say I get a number that's non-zero. Okay, move my paper up here. If I get a number that's non-zero, then what happens when I take the square root of a number? Right? We always wrote this, that plus minus value. Okay, so if I do that, then that tells me that I have 2 solutions there, or 2 outputs. Okay, and if we remember our rules, when we have one for every input, we can only have one output. So that would be not a function. Okay, last two. Y equals 3x cubed minus 8. All right, this is called a cubic function. Okay, so if I plug in, let's say the number 1 here, 1 cubed is 1. 1 times 3 is 3. 3 minus 8 is -5. There's no other number I could get for inputting 1. So this would be a function. Okay, down here, let's say I plug in, let's plug in the number, if I plug in 2 here, I get 8 times 2 is 16. 16 minus 7 gives me 9, right? So 8 times 2 minus 7. So y squared equals 8 times 2 minus 7. Y squared equals 8 times 2 is 16. 16 minus 7. So 16 minus 7 is going to give me 9, right? So then how would I solve for y? Well, I take the square root of both sides, right? But y, now the square root of 9, that could be 3, but it could also be negative 3, right? Okay, so since that gave me 2 outputs, that is not a function.